Good morning,
Good
sir.
morning, sir.
Can you read the screen?
Good morning, sir.
स्क्रीन पे क्या दिख रहा है बच्चों?
Welcome to chemistry class.
Welcome to chemistry.
पूरा बोलो. हेलो.
Welcome to chemistry class date 6/1/2021.
Thank you. That means you can see the screen well. Now let's move forward and revise what we have studied into the last period. So my dear student, in the last period we have studied about how to calculate the average atomic mass. So we learn how to calculate the average atomic mass. For that we have solved even one problem. So first let us see what is the formula to calculate the average atomic mass. Average atomic mass is equal to the atomic mass of isotope 1 multiplied by the percentage of isotope 1 divided by 100 plus atomic mass of isotope 2 multiplied by the percentage of isotope 2 divided by 100. That means we need percentage of isotope when we want to calculate the average atomic mass. Sometime instead of percentage, they give us ratio. So that also we have solved in the last period, that how we can convert the ratio into the percentage. Now, if you have more than one or more than two isotope, you can even write it further, that the plus the atomic mass of isotope 3 multiplied by the percentage of isotope 3 divided by 100. But generally we like in 9th standard we have it for calculation for two isotopes. So I have make it limited up to two isotopes. So now my dear students, let us revise how did we solve the question. The question was chlorine occurs in the two isotopic forms. Uh, one has got the atomic mass 35U and another has got the atomic mass 37U, and the ratio is given as 3:1. So my dear students, we can solve this ratio first. How we can get the finding percentage from ratio? How we can convert the ratio into the percentage? So first we write the ratio 3:1. Then we take the sum of the ratio. So next step is to take the sum of the ratio. So we take the sum 3 plus 1 is equal to 4. Now what do? We take the percentage of isotope 1. So to calculate the percentage of isotope 1, we first take the ratio of that isotope. So the ratio of that isotope is 3. Out of 3:1, the ratio is 3. Then we divide it with the sum of the ratio, that is 4, and then we multiply it with 100. So that means, how do we get percentage? Percentage of isotope is equal to the ratio number divided by sum of the ratio multiplied by 100. This is how you do it. For the second isotope, the number of ratio is 1. The sum of the ratio is 4 multiplied by 100. And that is how we got 75% for the isotope 1, 25% for the isotope 2. And then we put the value. So the atomic mass of 1 uh, was 35 and it has got 75% divided by 100. The second isotope was having the mass 37U and it was 25%, which was divided by 100. And by doing all this required calculation, we find out that the average atomic mass of chlorine is 35.5. So sometime you may be asked that why the atomic mass of chlorine is a fraction, or it is 35.5, because the chlorine exists into the two various isotopes which have different atomic masses. So we calculate the average atomic mass, and as we calculate the average atomic mass for chlorine, we get the average atomic mass of chlorine 35.5, which is a fraction. Now, my dear students, we are going to solve the new problem. That is what it is. It is from your exercise. So let us solve one of your very important exercise question. If bromine atom is available in the form of say two isotopes, one is 35 Br79 and the percentage are given 49.7%, and another is 35 Br81 and its percentage are given 50.3%. Now please understand, my dear students, that in the subscript we write atomic number Z, and in the superscript we write atomic mass A. For calculation of the average atomic mass, we choose atomic mass, and these two atomic mass which are given here is for isotope 1 we have 79. For isotope 1, this average atomic mass that we calculate is 79, my dear student. And for the isotope 2, the mass given is 81, you can see here. So this is the atomic mass of isotope 179. This is the atomic mass of isotope 281. Their percentage are clearly given 49.7% and 50.3%. So now we have these values. Let us understand it that for data given for isotope 1 and for isotope 2, the representation is 35 Br79, 35 Br81. Therefore, atomic mass of isotope 1 is 79, atomic mass of isotope 2 is 81. The percentage of isotope 1 is 49.7%, percentage of isotope 2 is 50.3%, and therefore average atomic mass is equal to atomic mass of isotope 1 multiplied by the percentage of isotope 1 divided by 100 plus atomic mass of isotope 2 multiplied by the percentage of atomic mass 2 divided by 100. Now let us put the value. Atomic mass of isotope 1 is 79. The percentage of isotope 1 is 49.7 divided by 100 plus atomic mass of isotope 2 is 81. The percentage of isotope 2 is 50.3% divided by 100. Now what we'll do the calculation. For doing calculation, we multiply 50.3 with 81, and that is what we get the answer 4074.3. When we do the calculation 49.3 multiplied by 79, we get the answer 3926.3, and both these are divided by 100. As we have the same denominator, or if we divide these two numbers with 100, the decimal moves left side 2 decimal. So we get 39.263 plus 40.743, and by doing the addition of both these numbers, we get 80.006 which is simply approximately equal to, this is what it means, approximately, or sometimes they write roughly, ROUGH, roughly, approximately or roughly is equal to ATU. So for 80.0006 U, we take it as a ATU, and we can say that the average atomic mass of bromine atom is ATU. Now my dear students, if you could not understand anything, you can ask. बच्चों अगर इसमें कुछ समझ में नहीं आया तो आप पूछ सकते हैं. ये पूरा प्रॉब्लम सॉल्व किया मैंने. अगर इसमें आपको कुछ समझ में नहीं आया तो आप मुझे पूछ सकते हैं. कुछ पूछना है बच्चों? Dear students, do you have anything that you could not understand? Do you have any doubt? Please बोलिए. Do you have any doubt?
No, sir.
No, sir.
Thank you. Thank you
No,
for
sir.
replying, my dear child. Okay then, my dear students, let's move and solve the another problem. Let's move forward to solve the other problem. Let me read the question for you. The average atomic mass of a sample of an element X is 16.2 U. This is the average atomic mass they have already given us. What are the percentage of isotopes 8x16, that is your Z, that is your A. The atomic mass of isotope 1 is 16 and atomic number of isotope 1 is 8. Then you have the another, the atomic number is 8, 8x18. So the atomic mass of the second isotope A atomic mass of second isotope given is 18. So this is what we understand from the question. They have already given the average atomic mass. They have given us the atomic mass of isotope 1 and atomic mass of isotope 2 in the sample, and what we need to calculate is the percentage for both these samples. So we just need to find out the percentage of both these samples. Now my dear students, whenever we are given the percentage, the total of the percentage is always 100. The total of percentage is equal to 100 because all the percentage are based on the 100. Even if you look into the previous question, they have given us the percentage 49.7%, and then next one they have given us the 50.3%. If you add both of them, we will come to know that this gives us the 100, and that is why the total of the percentage will always be 100. So we can use this idea that the total of the percentage is always 100. We can suppose we can determine that the percentage of isotope 1 may have the percentage something, and the another one will have the percentage 100 minus that. Now here let us answer these questions. Here average atomic mass is 16.2, which is already given. For isotope 1, if you look, the atomic number is 8 and atomic mass number is 16. For isotope 2, the atomic number is 8 and atomic mass is 18. So atomic mass of isotope 1 is 16 and atomic mass of isotope 2 is 18. Total percentage of isotope 1 and isotope 2 are 100, and therefore my dear students, we can write that percentage of isotope 1 plus percentage of isotope 2 is equal to 100. Let us say the percentage of isotope 1 is X. Let us say that the percentage of isotope 1 is X, and therefore we can put the percentage of isotope 1 is equal to X plus percentage of isotope 2 is equal to 100, and therefore my dear students, the percentage of isotope 2 is equal to 100 minus X. That is what we get. So the percentage of isotope 1 is X and the percentage of isotope 2 is 100 minus X. That is what we can easily understand. Now my dear students, let us write the formula to calculate the average atomic mass. We are well aware that the average atomic mass of an element is equal to atomic mass of isotope 1 multiplied by the percentage of isotope 1 divided by 100 plus atomic mass of isotope 2 multiplied by the percentage of atomic mass of isotope 2 divided by percentage of atomic mass of isotope 2 multiplied by the percentage of isotope 2 divided by 100. Now let us put the various values. Atomic mass of isotope 1 is 16. Atomic percentage of atomic mass, percentage of isotope 1 is X divided by 100. Atomic mass of atomic mass of isotope 2 is 18, and percentage of isotope 2 is 100 minus X divided by 100. And we are well aware that in question itself, it is given that the average atomic mass is equal to 16.2. So for average atomic mass, we write 16.2. Now, my dear student, we are well aware that if we have A divided by X plus B divided by X, we can write A plus B divided by X. This is what it is possible only when we have the denominator same. So here also the denominator is same, which is 100. So we can write 16 into X plus 18 into 100 minus X divided by 100. Now if we multiply this equation both the side with 100, if we multiply this equation both the side with 100, so we will write 100 over here, we will write 100 even on the right hand side. We can say that 100 divided by 100 is equal to 1, and 1 is need not to be written. So we will write 16.2 multiplied by 100 is equal to 16 into X plus 18 into 100. This 18 into 100 will give us the 1800, and 18 into X will give us the 18X. So this is how the next term we can write, that 16.2 multiplied by 100 is equal to 16X plus 1800 minus 18X. Now just look into these two. These both terms contain X. So we shall write them near to each other. This 16.2 multiplied by 100 is 1620, my dear students. We write this 16x minus 18x. We write this 800 as usual. We know that 16 minus 18 is equal to minus 2. So it is minus 2x. So 1620 is equal to minus 2x plus 1800. If we add both the side 2x, and if we add minus 1620 both the side, we will get 2x is equal to 1800 minus 1620. 1800 minus 1620 is equal to 180, my dear student. You can see that I have shown you the answer, that the answer is 180, and therefore 2x is equal to 180, and therefore x is equal to 180 divided by 2, which is 90. So my dear students, the percentage of isotope 1, which we have taken it as x, you can see that I have written it clearly here that the percentage of isotope 1, the percentage of isotope 1, we have taken it as a x, and for that x we have got the value 90%, and that is why we can say that the percentage of isotope 1 is 90. Now we are well aware that the total or sum of the percentage is 90. So the percentage of isotope 1 is 90, and therefore percentage of isotope 2, which we have taken as 100 minus x, but the value of x is 90, so it is 100 minus 90, which is 10%. So now we can say that therefore percentage of 8x16 is 90%, and percentage of 8x18 is 10%. This is how, my dear student, we understand the percentage very well. सो बच्चों, अगर इसमें अगर आपको कुछ समझ में नहीं आया तो आप पूछ सकते हैं. माय डियर स्टूडेंट्स, इफ यू कुड नॉट अंडरस्टैंड इन दिस एनीथिंग इन दिस प्रॉब्लम, यू कैन आस्क योर डाउट. प्यारे बच्चों, ये जो पूरी कैलकुलेशन हमने की अभी यहाँ से यहाँ लेकर यहाँ से यहाँ तक, उसमें अगर आपको कुछ समझ में नहीं आया तो आप लोग मुझसे पूछ सकते हैं. कुछ पूछना है बच्चों?
नो सर.
एवरीथिंग अंडरस्टूड? देख
यस
लो
सर.
एक बार फिर से, चलो अगर कुछ समझ में नहीं आया तो पूछ लो. Okay, then let's move to the next question, my dear students. Let us move forward to the next question. Let us see what is the next question. Tells us, if Z, that is the atomic number, Z is equal to 3, what would be the valency of the element? If the atomic number Z of an element is 3, what would be its valency? Now, if Z is equal to 3, my dear students, element has 3 electrons, because element is electrically neutral. It has 3 protons that we come to know from the Z is equal to 3, and that is why it has 3 electrons also. Now we know that we have various shells K, L, M, N, and we can put 2 electrons in K, 18 L, 18 M. But here we have total 3 electrons. So in first we can put 2 electrons, and in the second one we will have only 1 electron left, because 3 minus 2 is equal to 1. So we can write the electronic configuration for this element, which is having Z is equal to 3 is 2, 1. So now valence electron, you can see that the outermost electron are known as the valence electron, and here we have valence electron number is equal to 1. We are well aware that if the number of valence electron is less than 4, then the valency is equal to number of valence electron. So here the valence electron is 1, which is less than, see, I have written it wrongly. 1 is less than 4. So here we can say that the number of valence electron is less than 4, and that is why valency is equal to number of valence electron, and that is why the valency is going to be 1, my dear students. It's very easy for you to understand. Now let's look at the next question. Composition of the nuclei of two atomic species X and Y are given as under. So these are the nuclei of species. These are the nuclei. We have nuclei X, we have the nuclei Y. In the nuclei X, we have the number of proton is equal to 6. In the nuclei Y, we have the number of proton is equal to 6. But if we look into the nuclei of X, the number of neutron is 6, but here the number of neutron is 8. Give the mass number of X and Y. First thing what we need to do is to calculate the mass number. And what is the relation between the two species? We need to find out the relation between the two species also. So let us rewrite the question into a table. So first we have the serial number 1, 2, then we have the two elements X and Y. Then the number of proton is equal to 6 and 6, both of them. The number of neutron is equal to 6 and 8. And then we can calculate the atomic number. Atomic number is equal to number of proton. So Z is equal to P plus 1. So atomic number is 6 for X and atomic number is 6 for Y even. Now we will find out the atomic mass number. Atomic mass number A is equal to number of proton plus number of neutron. That is for element X, it is number of proton is 6, number of neutron is 6. So we can write 6 plus 6 is equal to 12. But for element Y, the number of proton is 6 and number of neutron is 8. So we will write 6 plus 8, which is equal to 14. Now we know we write the element into the notation. If the element is X, we write ZXA, where A is equal to atomic mass number and Z is equal to atomic number. So in the same manner, my dear student, we write it here. For X, we can write 6x12, and for Y, my dear student, it should be Y here. For Y, my dear student, we write 6y14. But here I have written X because the atomic number is same, and if the atomic number is same, my dear student, if the atomic number is same, this Jigar Barbaria is disturbing the class. Jigar, remove all this. Okay, so this is how we can say that the atomic number is 6x14. So actually the atomic number is same, and that is why instead of y, I have written x here. Actually we feel to write it y 614, but when the element have same atomic number, my dear student, we write it as a same symbol, and that is why I have written 6x14. And now you can see that both these elements have same atomic number but different atomic mass number, and that is why we can say that those elements which have same atomic number but different atomic mass number, they are called the isotopes of each other, and that is why this X and Y are not actually the different element, they are nuclei of the same element, and that is why they have same number of proton but different number of neutrons. So let us understand mass number of X is 12, mass number of Y is 14. Both X and Y have same atomic number but different atomic mass number. So X and Y are isotopes of each other. So that is how you understand. Now my dear students, let us move and understand the next question. When an atom become ion? When an atom become ion, that is what we want to understand, my dear students, that when an atom can be considered as an ion. So when an atom become ion, let us answer this question. When, my dear student, when an atom either lose or gain electrons, please remember, an atom either lose or gain electron, atom become ion. So please remember that for an element to become ion, the atom has to lose electron or atom has to gain electron. It is very important that the atom either lose or gain electron to become ion. When an atom become cation and why? Please understand, when an atom become cation, we know that cation is the positively charged ion. Positively charged ion. The positively charged ion is called cation, and when an atom become cation and why it become cation, let us understand it. It's interesting to study. When an atom possesses less than 4 when an atom possesses less than 4 electrons in its outermost shell or valence shell, it loses its electron or electrons and achieves octet in outermost shell. Does it make a cation? ये बड़ा ही इंटरेस्टिंग है माय डियर स्टूडेंट्स, मैं फिर से आपको बताता हूं. प्लीज ध्यान से इसको समझने का ट्राई कीजिए. When an atom possesses less than four elements, when an atom possesses less than four elements in its outermost shell or in its valence shell, it loses its electron or electrons and achieve octet in the outermost shell. Thus, it makes a cation. Let us understand this with the example. Let us say example of sodium. Sodium has got 11 proton and 11 electron because its atomic number Z is equal to 11. So we can write its electronic configuration 281. Now you can see that it has got only one valence electron. In sodium we have 11 proton. Now what happens, my dear students? This sodium loses its one electron from the outermost shell. So sodium becomes sodium plus one ion. When sodium loses its one electron, you can see that one electron is being lost by sodium. This one electron comes out from the sodium. This is the electron I am talking about, which comes out from the sodium. The electron that comes out from the sodium is this, my dear student. And that is why the new electronic configuration of our sodium plus 1 ion is 2,8. Now you know that initially there were 11 protons into the sodium. Now the proton remains same only because the electron comes out. But my dear students, if you look into the electrons, initially in the neutral sodium there were 11 electrons which was equal to the proton, and that is why the sodium was neutral. The sodium was neutral. But my dear students, when sodium loses its one electron comes out of it, and now as electrons are removed, the electronic configuration becomes 2,8, and 2 plus 8 is equal to 10, and now sodium plus 1 ion has got only 10 electrons. So now you can see that the charge is equal to, my dear students, the charge is equal to number of protons plus number of electrons. My dear student, we can calculate the charge very easily, and we know that the charge is equal to, we very well know that the charge is equal to number of protons plus number of electrons. Now here the number of proton, my dear student, in Na plus 1 ion is 11. Sorry, the charge is equal to number of protons minus number of electrons, that is where uh, so the charge is equal to number of protons minus number of electron. Number of proton is 11, number of electron is 10, and that is why it is plus 1. And that is why you can see that there is plus 1 charge present on the sodium atom. The same thing I have written here with the black pen, that total number of proton is 10, total number of electron is, total number of proton is 11, total number of electron is 10, charge is equal to number of proton minus number of electron, that is plus 1, and this plus 1 charge I have written here with the black pen. So my dear student, you should know that when an atom loses electron, it becomes positively charged and it forms the cation. Now if you look into the next example, magnesium. Magnesium has got Z is equal to 2, and that is why its electronic configuration is 282. Magnesium has got 12 proton and 12 electron, and that is why there is no charge on magnesium. What happens? The valence electron present into the magnesium, they are 2. Magnesium loses its 2 electron. You can see that this magnesium loses its 2 electron. So when magnesium loses its 2 electron, my dear student, this electronic configuration which was 282 now become 28. So magnesium has got 10 electron, but the number of proton in magnesium remains the same, that is 12. Now we know that, my dear student, now we are well aware that charge is equal to number of protons minus number of electron. We have number of proton is equal to 12, number of electron is equal to 10, and that is why the answer is plus 2. Sorry, my dear students. So as the answer is plus 2, we can write the charge on magnesium as plus 2. And this is how from magnesium plus 2 ion is produced when the 2 electrons are lost by magnesium. Same way, my dear students, let us understand it with the example of aluminium. Aluminium has got its atomic number Z is equal to 13. So it has got 13 electrons and its electronic configuration is 283. As aluminium does not have any charge on it, it is electrically neutral, and that is why it has both protons and electrons are equal. So aluminium has got 13 proton and 13 electron in its valence in its electronic configuration. Now if you look into the valence shell or outermost shell, aluminium has got 3 electrons. So aluminium loses its 3 electron, my dear students. You can see these 3 electrons are being lost by aluminium, and the electronic configuration, and aluminium turns out to be iron. When aluminium loses its 3 electron, the new electronic configuration is 2,8, where the octet is achieved and it has got 8 electron in the outermost shell. Here also when the ion is formed, you can see that there are 8 electrons in the outermost shell. Here in sodium also, whenever the ion is formed, you can see that there are 8 electrons in the outermost shell or the valence shell. So this element loses electron to make their valence shell to have octet. Now, my dear students, if you look into the case of the aluminium, dear student, you would come to know that initially this aluminium was having 13 proton and 13 electron. But now aluminium plus or aluminium ion is having 13 proton and 10 electron. We know that, dear student, that charge is equal to number of proton minus number of electron, and that is why the number of proton is 13, number of electron is 10, and that is why 13 minus 10 is equal to 3, and you can see that the charge on aluminium is plus 3. So this is how, my dear student, the cations are being formed. Let us understand with one more example the formation of the cations so that you can understand it well. Let us look into